All right, hey. Okay, so this video is going to go over the review for Unit 2 test, linear functions, day 2 of the review, which is taking place on Thursday, October 29th. Alrighty, so the first question asks us to evaluate these different algebraic expressions when x is a different value each time. So here we're given x is -6. So when it says evaluate, that means that we're telling you what x is, so you don't have to solve for it. We're telling you x is -6. You're going to take that -6 and plug it in for x. So -2 times whatever x is minus 3. Well, x is -6, so I'm going to plug that in, and then we're going to use PEMDAS to simplify. Whenever you're evaluating an expression, follow the order of operations. Okay, so we have multiplication and we have subtraction. So we're going to do the multiplication first. So -2 times -6 is +12. Okay, and then we have 12 minus 3, our subtraction, that's 9. All right, next one. Evaluate 3/4 x plus 2 when x is 12. So I'm going to take that 12 for x and plug it in. This 3/4 is being multiplied by whatever x is, right? When they're just smushed together like that, it's multiplication. So that's 3/4 times 12. Okay, so in your calculators, you can do 3ABC4 times 12. And you get 9. Okay, if you don't have your calculator, just know that this is the same as multiplying as like 12 over 1. So 3 times 12 would be 36. 36 divided by 4 times 1. That's another way of doing it. 36 over 4, which is 9. Okay, we did our multiplication. As like PEMDAS says, do multiplying and dividing before adding and subtracting. Now let's do the adding and subtracting. 9 plus 2 is 11. Okay, let's look at C. 5/6 x minus 4 when x is -6. So I'm going to plug in for x my -6. And let's use our calculator again. 5ABC6 times -6 is -5. We're multiplying before we're subtracting. Now let's subtract -5 minus 4. So you could go ahead and use your calculator again for that if you want. You're going to get -9. Okay, let's move on. Now we have to solve. So that was evaluating expressions. Now we need to solve. So when you're solving for x, you're going backwards. You're undoing the operations in the equation to figure out what that missing piece is that we started with. So let's keep that in mind. Okay, I'm going to draw a line through my equal sign. And then I noticed that I have x's on both sides here, on the left and the right. We need to get all of our x's together on one side, so then we can solve for just that x that's going to then just be represented all together. So I'm just going to make a note of that so we don't forget. We need to move all our terms with x to one side. All right. Okay, so I'm going to just move all my x's over to, let's see, I have 5x over here, I have 8x over here. I'm going to try to avoid negatives, so I'm going to take my x's and move them onto the right because I know 8 minus 5 will avoid some negatives. But you could always move your x's all to the left if you prefer. But I'm going to move them to the right this time to avoid negatives. So when I say move, I'm saying I'm taking this entire term, this 5x, and I want to pick up the whole thing and move it over to the other side. So to do that, I'm going to use inverse operations. So the opposite of a positive 5x is minusing 5x. 5x's minus 5x's is going to cancel and give you 0 x's on that side. Okay, and then I'm going to bring down my -2. Remember that -2, that minus is like a negative. Keep it with the number behind it. 8x's minus 5x's is 3x's. Bring down my -11 or my -11. Okay, now I need to get all my constants to the other side. I'm trying to get my x here by itself. So I have to first move this constant, this -11. We're doing PEMDAS in reverse now since we're undoing the equation to find the x. So therefore, we're going to do the adding and subtracting first before we undo the multiplication and the dividing that you see right here. So let's add 11 on both sides. -2 plus 11 gives me 9. Bring down my 3x. Now the opposite of multiplying by 3 is dividing by 3. 9 divided by 3 is 3. My x is 3. All right. Let's look at the next one. So again, we have variables on both sides. We have y's on the left and we have y's on the right. We want to get them all to one side. But before we do that, we also have something else going on here. We have some terms that we can combine. So before you move all your terms to one side, you want to think, is there anything that I should combine? Okay, so you want to combine like terms first. All right, so I'm going to combine my constants. So I still have my 2y, negative 8 plus 4 is negative 4. So I'm going to write 2y minus 4 equals 3y plus 6. Now I want to get all my y's to one side. So again, I'm going to think, how can I avoid having some negative y's? Because I really don't like negatives if I don't have to deal with them. So in order to do that, let's see, I'm going to minus my 2y on both sides because I know 3y minus 2y will give me a positive amount of y's. Then I'm left with negative 4 equals 1y plus 6. Move all my constants to the other side. Minus 6 on both sides. 6 minus 6 cancels, that's 0. Now I have 1y equals negative 10 because negative 4 minus 6 is negative 10. Alrighty, and 1y equals negative 10. I mean, that's the same thing. We could divide both sides by 1, but you're going to just get the same thing, negative 10. That 1 could be an invisible coefficient. So we end up with just y equals negative 10. Okay, and I don't really have room to check it on here, but just remember that you can take this negative 10, plug it back into your original wherever you see a y, and both sides should balance out. Same thing with this 3 equals x. Plug that 3 in for the x here and over here, and both sides should balance out. So I strongly recommend you do that on the test if you have time. Okay, number 3. Identify the slope and y-intercept of each line represented as an equation, a graph, a table of values, or 2 points that fall on the line. All right, so first up we have a graph. To find the slope from a graph, you have to do rise over run. Change in y over change in x. The change in y would be the rise, the up and down. The change in x is the run when you go side to side. All right, so there's tons of points here that we can work with. I'm going to just pick this one and this one. Going from left to right is the easiest. To get from this one to this one, we're going to have to go down 1 and then right 1. So that means my slope, my rise, is going to be down 1, and my run is positive 1. Simplify. Negative 1 divided by 1 is negative 1. All right, my y-intercept. The y-intercept is where this line crosses the y-axis, which is right here because our y-axis is this line, and this is our line. It crosses at 2, so the b is 2, but the point would be 0, 2. The y-intercept is wherever the line crosses the y-axis. Okay, now let's look at function b. To find the slope in a table, we're going to think of slope as change in y over change in x. So the change in y, I notice that these are all going up, and they're going up by 1 each time. My change in y is 1. That goes on top. My change in x goes on the bottom, the denominator. And I notice, you could start at the easy one if you want. From 2 to 4, we're going up by 2. We're going up by 2 each time. If you're not sure to figure out, you could check by saying, is negative 2 plus 2 0? Yeah. Is 0 plus 2 2? Yeah. 2 plus 2, 4. And go backwards. 4 minus 2 is 2. 2 minus 0 is 2. 8 minus 7 gives you that 1. Okay, so my change in x is 2. So my slope is 1/2. All right, and my y-intercept. The y-intercept is whenever the x is 0, that's it. That's your y-intercept, that point. So here the x is 0, so that means my b is going to be 6, and my point is 0, 6 for the y-intercept. 0, 6 would lie right on that y-axis. Okay, now the second question here says, using the words less than, greater than, or same as, write a sentence comparing the rate of change of function A and function B. Okay, so let's see. I'm going to let's see if I can just pull this off. All right, yeah, okay, that works. So this is what we just did, and now this is what we're doing on the next page. We're comparing them. So we're comparing the rate of change. So the first thing that you have to know is that rate of change is the same thing as slope. So the slope of function A is -1. And the slope of function B we found to be 1/2. So you have to compare them. -1 is less than 1/2. So therefore the rate of change of function A is less than the rate of change of function B. So again, the rate of change of function A, which is -1, is less than the rate of change of function B, which is 1/2. Okay, so we just compared the rate of change. Just remember, rate of change is slope. Okay, let's do another one. Now we have 2 points. So we have to find the slope between 2 points. All right, so there's 2 different ways you can do this. The first way is using our formula, where you have to label these as, they always go x, y every point. So this is x number 1, y number 1. This would be the second x and the second y. Our formula is change in y over change in x. So y2 minus y1 over x2 minus x1. When you say change in, we're really just subtracting them. So to plug it into our formula, I'm going to subtract my y's. I'm going to go from back to front. y2 is -1 minus y1, which is my -5. Sometimes it helps if you write them like this in parentheses, so you don't forget any of the negative signs. So -1 minus our -5. Now let's do our x's. Back to front. x2 is -1 minus our x1, which is 0. Okay, you could put this whole thing in the calculator, but you have to remember that in minusing a negative turns out into being positive. Or just type the whole thing in your calculator. So this is really -1 plus 5, which is 4. And then -1 minus 0 will give me -1. 4 divided by -1 is -4. My slope is -4. Okay, now I'm just going to show you if you wanted to do it by looking at a table. Sometimes that's easier for you guys to avoid messing up the negatives there. So just list the points. The first point is 0, -5, xy. xy for the next point is -1, comma, -1. Change in y over change in x. The change in y. To get from here to here, oh man, I don't know, because negatives are really hard. So maybe I'll go backwards and subtract. -1 minus, -1 minus that -5. It's 4. Positive 4. Not sure? Let's check. -5 plus 4. Yeah, that gives me my -1 down here. Cool. Okay. How do I get from 0 to -1? If I'm not sure, let me go backwards and subtract. -1 minus the 1 before it. -1. Let's check. Is 0 minus 1 going to be -1? It is. So my slope is 4 over -1. Change in y over change in x, which simplifies to -4 again. Okay, the y-intercept. The y-intercept is just whenever the x is 0, whatever that y point is, that's the y-intercept. So if we look at our 2 points right here, this one has an x-coordinate of 0, so that means it must be the y-intercept. So it's 0, comma, -5. Okay, for our graph, to find slope in a graph, you do rise over run. So I'm just going to pick these 2 points up here. You could pick whichever ones you want because slope or rate of change is constant. It's the same throughout the whole graph when you have a linear equation, linear function. All right, so to get from this one to this one, I'm going from left to right. I have to go up 3, right 1. So therefore, my slope is 3 over 1. We're doing rise over run. On a graph, rise over run. Change in y, change in x. Okay, so 3 over 1, which simplifies to 3. Okay, our y-intercept. Y-intercept is where our line crosses the y-axis. So here's the y-axis. Our line crosses it right here at the point 0, 0, the origin. Okay, now I need to compare these two, the rate of change. rate of change is the same thing as slope. My slope of function A is -4. My slope of function B is 3. Which one is greater? So let's see. I'm going to start off my sentence by saying the rate of change of function A, which is -4, is blank the rate of change of function B, which is 3. Okay, now I have to fill in the blank. The rate of change of A is, well, let's see, -4 is smaller than 3, so -4 is less than. So this one is less than. I don't know why that's capital. Don't tell your English teachers. It's supposed to be lowercase. Now it just looks like a mess. But anyway, the rate of change of function A is less than the rate of change of function B. You're comparing the slopes. This one has a smaller slope than this one. Okay. All right, let's look at these two. Function A and function B. Function A is a formula, an equation, I mean. So we're going to compare it to our formula. Y equals mx plus b, and function B is a table. So looking at our formula, y equals mx plus b, the m is the slope. And the b is the y-intercept. So our slope is our number in front of the x. So here our slope is 1. And our y-intercept, well, if our b is 5, that means it goes through the point 0, 5, because the x is always 0 in y-intercept. Okay, and now let's look at our table. To find the slope in a table, we want to do change in y over change in x. So let's see, how much are our y values changing by? To get from 2 to 5, we're going up by 3. 5 plus 3 is 8. 8 plus 3 is 11. Not sure, go backwards and subtract. 11 minus 3 is 8. 8 minus 3 is 5. I'm sorry, to check it, you would do 11 minus 8 is 3. 8 minus 5 is 3. 5 minus 2, you'd get 3. To check it, you do 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. Change in x. How much are these changing by? First off, I would think, are they going up or down? These numbers are actually going up. They're getting closer and closer to 0, and then after that, they'd enter the positives. So we're going up. So we're going to be adding. -9 plus what equals -6? If you can't think about that because of the negatives, go backwards. -6 minus the one before it. You're going to get +3. -9 plus 3 is -6. -6 plus 3 is -3. And -3 plus 3 will give you 0. Our change in y is 3. Our change in x is 3. Our slope is 3 over 3, which simplifies to 1. Okay. Our y-intercept. The y-intercept is whenever the x is 0. So just look through your table and look through your points, whatever you're given. Find where the x is 0. That one is the y-intercept. Because if the x is 0, it's not moving left or right on that x-axis at all. You're staying at 0, and then you're just going up or down on the y-axis. So that is our y-intercept. So here it's going to be the point 0, 11. Okay, and now one last time we're going to write a sentence comparing the rate of change from function A and function B. Okay, so we have a slope of 1 for function A. Remember, slope is the same thing as rate of change. And here we have a slope of 1. 1, 1. The rate of changes are the same. The rate of change of function A is the same as the rate of change of function B. They are both 1. Okay, and our last question for today. Label the following graphs based on their type of slope. Okay, so the 4 different types of slope. We have positive, That would be as you go from left to right, the line's going upward. Think like you're walking uphill. As you read from left to right across the page, you're going uphill. Negative would be going downhill as you look from left to right across the page. Then we have a zero slope, which is always our flat horizontal line. Think like zero, like the Z in horizontal. And then lastly, we have undefined. That's going to be our vertical lines. Okay, so I basically just said all the answers. But positive is going to be the one going upward. So right here, this one is going upward as you go from left to right. So C is positive slope. Our negative slope is going to be B. As you go from left to right, we're going downhill, downward. So B is our negative slope. A is going to be our undefined slope. It's a vertical line going up and down. Vertical line. Vertical, the V in vertical is kind of similar to a U. They're almost like the same letter if you ask me. So V and U, you could try to remember undefined vertical go together. V and U are similar letters. So A is undefined. And then lastly, we have our line going horizontal straight across. That's going to be our zero slope. A good way to remember it is the word horizontal has a Z, and so does zero. Oops, there you go. Okay, so hopefully that helps you guys with your studying. Thanks for watching. Again, this was going over the lesson from Thursday, October 29th, which is review day number 2 for your linear functions test. That is the next day, October 30th, Friday. All right, bye.